So I want to draw you a diagram of a mid-ocean ridge system and explain what's going on there. So take a moment, pause the video, and make yourself a copy of what I have on the screen already, and then come back and we'll continue to label it and talk through what's going on. Okay, so what we're looking at is a side view, as if we've cut down through the ocean and the seafloor to see what it looks like from the side. So let me start labeling things so you can see what's going on here. So on the right, we've got some continental crust, which just means this is land. So the United States, North America, all the continents that you see on the globe are made out of continental crust. So it's sticking up above the ocean. Got some trees there and a little building. And continental crust is made out of a rock called granite for the most part, which is different than what the ocean floor is made of. So the ocean floor we call ocean crust or oceanic. Oops, okay. And the rock that makes up the ocean crust is called basalt. And one of the reasons it's important to note these different types of rock is that they have different densities. So it turns out that the ocean crust rock basalt is more dense than what the continent is made of, the granite material. Okay. So the mid-ocean ridge itself is this feature on the diagram. So let's label that. So if you remember, a mid-ocean ridge is literally mountain range system that's found on the seafloor. So let's see, what should we do next? Let's add what's happening at the ridge. So I'm going to switch colors. So the mid-ocean ridge is a place where molten rock erupts out of the mountain range down there, the ridge system. Right. So the hot liquid magma rises through cooler material and erupts out of the mid-ocean ridge. That's what those red arrows represent. And of course, the hot material rises because it is less dense than the stuff around it. All right, so that material, that hot liquid rock, erupts, hits the cold seawater, and very quickly cools into solid new rock. And that's new material. So we're adding material to that ridge area, which forces the ocean crust to separate. That process repeats, and with every eruption, we're adding new rock to that mid-ocean ridge, which forces the ocean crust pieces to move farther apart. And essentially, we are causing that ocean basin to expand and get bigger. All right, so let's be clear that this is a boundary between two tectonic plates. So we can label them up here just to be clear about where the boundary is. So we have plate 1 and plate 2. And the boundary between them is at the mid-ocean ridge. So in terms of this rock, we've got the newest rock forming right at the ridge. And as you move away from the ridge in either direction, the rock gets older. So this is a boundary that is moving apart. So we're going to add, let's use purple, some big arrows to emphasize what motion is happening at this boundary. So these plates are moving away from one another. And the fancy word for moving apart that we use is divergent. So this is a divergent plate boundary. So a mid-ocean ridge is a divergent plate boundary where two plates are moving away from each other because new material is being formed at the ridge each time an eruption happens. And the one last detail we need to add to all of this is that not only do we get these underwater volcanoes and an underwater mountain range, this whole process creates earthquakes. So that's why looking at the map, you see that trace of shallow earthquakes along the mid-ocean ridge system. Okay, I think I'm just double checking that I got everything on my diagram, and it looks like I do.